Consider the equation 1 plus 2k x square minus 10x plus k minus 2. Find the set of value for k for which the equation has real roots. So whenever I say any quadratic equation which is in the form of ax square plus bx plus c equals to 0, this equation will have the real roots only when the discriminant of this equation, which is nothing but b square minus 4ac, would be greater than or equals to 0. So now when I compare these two equations, in place of a, we have 1 plus 2k. And in place of b, we have minus 10. And in place of c, we have k minus 2. So now, if I substitute these information here, so it's going to be minus 10 whole square, minus 4 times, a is nothing but 1 plus 2k, and c is nothing but k minus 2. And this must be greater than or equals to 0. So now, if I solve this, so minus 10 whole square would be 100, minus 4 into, so if I expand it, so 1 times k would be k, then minus 2, then 2k times k would be positive 2k square, then minus 4k. And if I further simplify this one, so 100 minus, so this k minus 4k would be minus 3k. And if I multiply this minus 4 to that one, so minus 3k, and multiplied by minus 4 would be positive 12k. Then minus 4 times minus 2 would be positive 8. Then minus 4 times minus 2 would be minus 8k square. And this has to be greater than or equals to 0. This thing can also be rewritten as minus 8k square plus 12k, then plus 108. And if I have it something like this, so I can also divide throughout with 4. So if I do that, so I'll be getting minus 2k square plus 3k, then 102 divided by 4. So that's going to give us something like 27. And whenever we want to solve this quadratic inequality, we need to think about factorizing it. In order to factorize it, so we need to find the factors for minus 2 times 27, so which is nothing but 54. And the factors for 54 would be 9 and 6. So it's going to be, of course, for minus 54, it has to be positive 9 and negative 6. So in that case, I'm going to split the middle term something like this. So I have minus 2k square plus 3k plus 27 must be greater than or equals to 0. So in order to factorize it, I'm going to split the middle term. So it's going to be minus 2k square, then plus 9k, then minus 6k, then plus 27. And here I can take k common out. So if I take k common out, so it would be minus 2k plus 9. And here, if I take minus 3 common out, so it would be, if I take plus 3 common out, so it is going to be minus 2k plus 9. So this thing can also be written as k plus 3 multiplied by minus 2k plus 9. So whenever we have any quadratic inequality, if I need to solve this quadratic inequality, so we should always think about drawing a sign diagram. So on the sign diagram, we should mention the roots of it. So roots, we can find it by equating these factors to 0. So if I equate this k plus 3 to 0, so I'll be getting k as negative 3. At the same time, if I equate minus 2k plus 9 to 0, so I'll be getting k as minus 9 over minus 2, which is 9 over 2. So in that case, on the number line on the sign diagram, so it would look something like minus 3 and 9 by 2. So we have to check which region it satisfies. If I take any value which is lesser than minus 3, let's say minus 4. So if I replace k with minus 4, so minus 4 plus 3 would be, it is going to be a positive negative value. And here, if I put minus 4, so minus 2 times minus 4, that would be positive, and this entire thing would be, so we will be getting it as positive. So if this is positive, so negative times positive, and this is greater than or equals to 0, that does not satisfy. So I'll put it as negative. So next, if I pick any value between minus 3 to 9 by 2, so let's say I pick 0. So if I replace k with 0, so I'll be getting 3, which is a positive value. And here I'll be getting 9, which is also a positive value. So any positive value would be always greater than or equals to 0. So it satisfies. Next, if I talk about any value after 9 by 2, which means after 4.5, maybe 10. So 10 plus 3 would be 13, which would be positive, and minus 20 plus 9, because we are taking k as 10. So minus 20 plus 9 would be negative. So plus times negative would be, so it would be negative, and any negative number will never ever be greater than or equals to 0. So that's why it doesn't satisfy. So for the k value, it satisfies us any value between minus 3 to 9 by 2. And this is the right answer for the sum.